sure that I'm recording the right channel. All right, so everything is good. Ready to go. Okay, so today, what we'll do today is to talk about nested statements. Okay, nested statements, is something that I showed you a little bit on the other day on Tuesday. I showed you a program that has a loop inside a loop. That's basically what nesting is about. Is how do you have one statement inside another statement? Now that's a very important concept because even though we have covered all the control structures already, in other words, as far as control structures are concerned, in other words, control structure refers to programming concepts where the execution path can change. A conditional statement is one. Okay, you come in, and then at a certain point you have to make a decision to go in one of two directions. Okay, but the two directions, each path will have to merge at the end when you exit the conditional statement. So that's one way to alternate to change the execution path. A loop is another way to change the execution path because with a pre-checking loop, when you come into a loop, then you can make a decision. Do I even want to go through the iteration once, or can I exit the loop right away? But if you decided that you have to perform one iteration, after that iteration, you have to go back to the same point, and then you have to evaluate the condition again. If it is true, you have to perform another iteration. If it is false, you get out of the loop. A post-checking loop is also, potentially can alter the execution path because you have to perform the action first. Then you have to decide, do I want to perform another iteration? So at that point, you have a decision to make. Should I go back, or should I continue with the next statement? So these three are basically the only execution path altering mechanism, which we also call control structures, that you have to understand. Now there are variations of these. Okay, like a for loop in C is a variation of a pre-checking loop. I'm not going to go over the alternate, versions of all of those particular control structures. So as far as that control structures are concerned, we are done already. So we only have conditional statements, pre-checking loop, post-checking loops, and the normal sequence, right? One statement after another, the most boring kind of control structure. If we have to write all kinds of algorithms only using these four basic concepts, that's quite limiting. Okay, so what we need to do is to understand how can we nest or embed one type of statement within another type of statement, and that's what this particular slide is about. This is what this module is going to talk about, and this is a very important topic. I will pass the row sheet at this point. And we talked about this part already. How those control structures, they're all very useful, but they cannot. Each one cannot do a whole lot. We have to combine them in order to do something that's meaningful. I just clicked the wrong link. Okay. So moving on to an example. We talked about this example on Tuesday already. Line 1 is one statement. Line 2 to 4 is considered one pre-checking loop statement. But within that statement, we also have line 3 as an assignment statement that is embedded inside the while loop. This is also why we use indentation, because indentation makes it easier for us to see which statement is within which other statement. It also makes it easy to find the end of a particular statement. Now, some people look at this example and go like, yeah, we can clearly see that line 2 is the beginning of the while loop, and we can clearly see that line 4 is the end of the same while loop. So what is the big deal of having to indent line 3? Well, that's only because this loop and this entire algorithm is so short. Okay, but what if the while and the end while are separated by many lines, 10, 20 lines? Then it's not as easy to tell, oh, this is the beginning and that's the end anymore. With indentation, it's still easy to tell, but without indentation, it will become kind of difficult to tell the difference, or to find the end of a particular construct. And that's why we have a more complicated, more complex example here, which is a little bit more difficult to see if I do not use indentation. But with indentation, because the while and the end while have exactly the same indentation, if you use a ruler just to line them up, you can clearly visually see this is the beginning and that's the end of that particular beginning. This is the beginning and this is the end of that particular while loop. So that's why we use indentation. It's not something that the compiler needs. The compiler can do everything on a single line. But what we need as a programmer would be indentation so that it's visual to us. What I'll do today will be a little bit boring to people who have read through the entire section and has gone through the whole thing and understood how it works, but it will not be so boring for people who did not read it ahead of time. Which is not to encourage people not to read my notes ahead of time. Let's say, let me just put it this way. As we go through this example, if you think it is boring, you're at a good place. Okay, you're at a good place in this class. You're getting through all the material. So I'll just go ahead and copy everything here. Okay, so I can I only have to refer to the spreadsheet and not to the original document anymore. And I will do this without indentation first until somebody says, please, can you please add the indentation back to it? Just to illustrate, the effect of not having indentation.
Now's a good time.
All right, so this is our sample program. We'll go ahead and create a folder for today. This is 2013. It is the 7th. All right. And just like with all your homework assignments, I'm going to use a separate sheet for the trace. We do have conditions to evaluate here, so we have one column for comments, one column for line numbers. We have 3 variables in this case. We have the sum, x, and y. These don't need to take up that much space. And now we are ready to go. The precondition is I really don't need to know the initial values for the sum, x, and y, because they will all be changed before the first time I refer to them. So that means they don't need to be initialized. All right. So let's start with line 1. Line 1 doesn't do a whole lot. X gets 0. So we go to column D and say, okay, x is now updated to a value of 0. Line 2, we go to column C, which is the sum variable, initialized it to 0, 2. Line 3, we have to evaluate x is less than 3. Is that true or is that false? It is true because x has a value of 0 at this point, so x is less than 3 is true. Where did we go? Line 4, okay, that's pretty easy. So far, the point about nesting, really has not bothered us. So at this point, y is initialized to 0. And now we have line 5, which is the beginning of another pre-checking loop. This time we have to compare y to 2. Y is less than 2 is true. Okay, so where do we go? Line 6. Line 6 is pretty easy. We are incrementing y by 1, so y goes from 0 to 1. And then we go line 7. Line 7 is trying to add up all the values of of all the variables. So we have sum y, x, and y. 0 plus 0 plus 1 is 1. But instead of saying 1 here, well, I guess in this case I can just put a 1 here instead of using the formula in the spreadsheet. Now this is a good point to kind of pause and then think about it and go like, okay, now what do we do? Because we are at the end of a pre-checking loop. Okay. Now we already know that the difference between a pre-checking loop and a conditional statement is with a conditional statement you just move on to the next statement. But with a loop, after one iteration, you have to go back to the beginning of the loop. But now we have 2 beginning to go back to, potentially to go back to. In other words, do we go back to line 3 or do we go back to line 5? That's the question. We go back to line 5 because the nesting of statements, each while is kind of like an open parenthesis, and then each end while is like a closed parenthesis. So they are nested in the same way as you use parentheses in expressions. So this is a closed parenthesis on line 8, end while is a closed parenthesis. But it's not closing the while that is starting on line 3, it's only closing the while that is starting on line 5. Okay? So that's why the next line to execute is line 5. Now, with a program this short, okay, it is still not very difficult to kind of go back and try to figure out which while we are ending. But with your program getting longer and longer, that will become an issue because visually it's difficult to find the beginning of that end while when the program gets longer. So what I'll do now is to kind of help to alleviate that particular problem by making use of indentation. So now we have all the indentations back. Does everybody see a difference? It's kind of better. It's better now. It's easier to see. Oh, this end while is ending this while. This end while is ending this while. Okay. All right. So now that we are back to line 5, we have to evaluate the condition of line 5 again. Y is less than 2 is true because y is 1 at this point. Y 1 is less than 2 is true. We go to line 6 again. It increments y to 2. Okay. But instead of just typing 2 here, I'm going to use a spreadsheet feature. The whole thing about using a spreadsheet is not to use it just like a regular table, like a grid, is so that I can automate some calculations. Okay? So this is not a spreadsheet class. I'm not going to spend too much time to talk about this, and you certainly do not have to do it the way that I'm doing right now. As far as you're concerned, doing your homework assignment, it's fine if you just write 2 here. Okay, that's perfectly fine with me. But just so that I can show you what a spreadsheet can do, you can start with an equal symbol on the cell, and then at that point it becomes a formula. A formula means the value of this particular cell, which is E11, can depend on other cells. In this case, it would depend on this cell, and then plus 1, which is 2. So instead of typing 2, I'm making the spreadsheet to do the calculation. So we end up with the same value of 2. Okay. And we go to line 7. Now on line 7, I can do the same trick here. I can say the new value of sum is calculated by the old value of sum, and then plus the old value of x, plus the old value of y, and now it is 3. Now you can say that yeah, but I can add 1, 0, and 2 quickly and come to the same conclusion as 3. Yep, that's definitely is true. But there are advantages to this approach, which I will show later. Okay, so we're back to line 5 again because line 7 is the end of the loop. We have to go back to the beginning. So now we have to ask the question again. Y is less than 2 is false. Now it is false. And then where do we go? This is kind of tricky.
Line 9.
We have to go to line 9. Very good, because we have to go to the statement that is right after the loop that we are getting out of. The loop that we're getting out of is this loop here from line 5 to line 8. So when this loop is terminating, we have to go to the next line, which in this case is line 9. All right, so we go to line 9, and all it does is to increment x